A university is interested in evaluating registration processes. Students register for classes by using either a telephone registration system or an online system that is accessed through the university's website. Independent random samples of 60 students who registered online and 80 students who registered by phone were selected. Of those who registered online, 47 reported that they were satisfied with the registration process. Of those who registered by phone, 57 reported that they were satisfied. Based on these data, is it reasonable to conclude that the proportion who are satisfied is higher for those who register online? Test the appropriate hypotheses using alpha equal to 0.05. Okay, the way we'll set the problem up is population 1 will be students registering online, and population 2, students registering on the phone. Two measures that we're interested in, the population parameters, P1, percentage of students registering online that were satisfied, and P2, the percentage of students registering by phone that were satisfied. And we're trying to determine the difference. We'll do P1 subtract P2. Our two samples, one from population 1 is 60 students registering online. 47 said that they were satisfied. And from population 2, 80 were sampled, and 57 said they were satisfied with registration on the phone. That gives us a difference of 0.0708 or 7.1%. That seems to indicate, or we have some evidence there possibly, that the percentage of students registering online that were satisfied is higher than the percentage of students registering by phone that were satisfied, the population percentages. Now we want to test to see if that's true. So set up a null and alternative hypotheses. We want to test to see if we can show that there was a higher percentage of students registering online that were satisfied. So that would mean that the P1 minus P2 would be greater than 0. In other words, if P1, the percentage of students registering online, was indeed higher than the percentage of students registering by phone, their difference would be greater than 0. And what do we have to reject to prove that? Just the opposite. So we'll set up our null alternative hypothesis in this way. We need to create a sampling distribution. We're testing against 0. This is an upper tail test. Alpha is equal to 0.05. Our critical value is 1.645. We need to find a standard error value. Now, the null hypothesis is assuming less than or equal to 0 with a difference between the two population percentages at 0 on the lower end, and we're assuming that's where our distribution is. Assuming that is assuming that the two percentages are equal. And if I assume that they're equal, how do I create the sampling distribution to reflect that? Remember, the sampling distribution, a hypothesis test, is constructed based on the assumption that the null is true. Then with our sample evidence, we bring that in to see if it contradicts that sampling distribution and therefore the null hypothesis. Anyway, we need to get the sampling distribution based on the null hypothesis assumption is true. And on the lower end, that difference being 0, how do I do that? Well, if I'm assuming the percentages are equal, then I have two sample percentages that are estimates of that. I'm going to go ahead and pool those sample percentages, sort of take a weighted average. Calculating, first of all, that pooled percentage, P bar. I'm going to take my plug into the formula, take the formula for that, plug in my values. gives me 0.7414, and then my standard error, I take that pooled percentage, multiply by the complement, and multiply by 1 over the sample size from the first population and the sample size from the second. Take the square root of the whole thing, and in this case I get 0.0746. So that's how I would calculate my standard error when I'm running a hypothesis test and running it comparing the differences to 0. Now I'm back with the hypothesis test, ready to write down my rejection rule. Reject H sub 0 if the test statistic is greater than 1.645, and the test statistic turns out to be, taking the difference in my sample percentages, comparing that to what I'm testing against, and then dividing by my standard error, I get 0.949. And so step 5, I do not reject H sub 0 since 0.949 is less than 1.645. In other words, the evidence that I had there that there was a higher percentage of students registering online that were satisfied as opposed to the students registering by phone is not strong enough to get the rejection and prove that the students registering online has a higher percentage of satisfaction. So do not reject. It doesn't prove the null is wrong based on a 0.05 level of significance, and certainly to avoid type 2 error, I do not want to say that the null is true. So I, in some sense, it's inconclusive. I've really proven nothing. Now, I want to also go and talk about the p-value here. I can run this test with a p-value. This is standard normal, and this is a one-tailed test, so how would I calculate the p-value? Well, I want to look at the test statistic, and table's resolution is hundredths, so I'm going to look up 0.95 as a z-value. This is an upper tail test, so my p-value is going to be 1 subtract the value from the table I get for 0.95, which is 0.8289, and then that is equal to 0.1711. So my p-value is 17.11% or 0.1711, and that is greater than 0.05. So again, this will agree with our conclusion that we had earlier by comparing the test statistic to the critical value. Do not reject H sub 0. We don't have evidence to prove that that this difference is greater than 0, that the students registering online, a higher percent of them are satisfied as opposed to students registering by phone. The value, another comment here, the this difference value of 0.0708 is about right there because its z-value or test statistic is 0.95 less than 1.645. So I know that 0.0708 is to the left of my decision line because simply its location, it's closer to the center. There's only 0.95 standard units from the center out to it. My decision line is 1.645 standard units away from center. So just comparing the test statistic to the critical value, I know that I'm not far enough out. The evidence isn't strong enough to get the rejection. Looking at it from p-value, the p-value is the probability of getting anything less likely. So the p-value here is 0.1711 greater than 0.05, and therefore again I'm on the left side. I'm a little closer to center than I was willing to risk when I would say that the null is wrong. So I'm not going to say the null is wrong. P-value is larger than the level of significance. My risk is higher in making a type 1 error if I reject the null. Again, comparing a p-value to the level of significance will conclude the same as comparing a test statistic to a critical value. They'll both agree. And in each case, I'm shown that the evidence there of the 0.0708 is just not strong enough based on standard error.